So for the baking soda and vinegar rocket experiment, I actually did it 3 different times. Um, the first 2 times really failed. I couldn't get the cork right because I couldn't tell in the video how exactly it was made. So I was kind of playing around with that, and then my pencils weren't staying, and they were too short at the first time. And then the third time I did, I mean, it went off the ground. It just wasn't as successful as the video um, that was demonstrated on Blackboard for us. So the experiment process, I mixed baking soda and vinegar in a bowl, and I took an empty water bottle and put 3 wooden pencils to the side of it with duct tape. And then I took 1 spoonful of that mixture and I put it in the middle of a paper towel, rolled it like a burrito, and rolled the ends of that burrito like a cigar. Um, and then I put a funnel onto the water bottle and I poured vinegar into the water bottle till the water bottle was about 3/4 full. Um, I then put the paper towel that looked like a cigar into the water bottle, and then I put the cork. I just made it out of paper towels because that's kind of what I thought it was from the video, but I'm not really for sure if that's exactly what it was. And then I shook the bottle, and then I turned the bottle upside down quickly onto the pencils, and my pencils so in the left picture, my pencils, I don't know how this happened, but my pencils slid down, and so, well, they would slide up, I guess, in this case, and the water bottle slid down, so it was like even. And then that picture on the right is actually the aftermath of it going up in the air and a little bit and coming back down. So how does this all work? The reaction between the baking soda and vinegar is an acid-base reaction. When the two combine, gas is released, and then the cork is there to stop the gas from escaping. The force of the gas pushes the cork out, making the bottle fly. The baking soda and vinegar react with one another because they both have a lot of energy that they don't want, and they can help each other get rid of it. An acid, in this case vinegar, is a chemical that wants to get rid of a proton or positively charged hydrogen atom. And then the base, and then in this case the baking soda, is a chemical that wants a proton. When you mix the two together, exciting things can happen, and because the acid is ready to give away its proton and the base is right there to receive it. Water is often added to acids and bases to tone down the intensity of this exchange. Water also acts as a host in which the acid and base can break apart and react. In water, baking soda breaks apart into a positively charged sodium ion and a negatively charged bicarbonate ion. An ion is a charged atom or molecule. Acetic acid doesn't break apart on its own in water as much as sodium bicarbonate, and it's mostly dilute, so it's not as strong. When we mix baking soda and acetic acid and water together, the acetic acid gives its proton to the broken apart baking soda, and together they form sodium acetate, water, and carbon dioxide. These products are created quickly, and the carbon dioxide comes out as a gas. By reacting with each other, the acetic acid and the basic sodium bicarbonate give up a lot of their energy and create things that have a lower energy relative to each other. The universe favors things at their lowest energy. So different reasons. Baking soda and vinegar react with one another because of an acid-base reaction. The baking soda is a bicarbonate and vinegar is an acetic acid. One of the products this reaction creates is carbon dioxide. Those two pictures are kind of like a quick little time-lapse thing of the experiment that I created. I did have my dad's help because they recommended doing it outside, and yesterday when I did it, it was very, very windy outside, and so that could also be why the experiment wasn't as successful, is because it was very hard to get the bottle to stay and just all this stuff, and like we did it all outside, so I poured it and I had my dad's help, and it was just a kind of a disaster, I guess you can say, but we tried to make it work. Some more reasonings: baking soda and vinegar react with one each other because of the exchange of atoms. We can also think of this as a proton as a hydrogen atom and that it's missing an electron. In this reaction, baking soda acts as a base and takes a proton from vinegar, which is an acid. The reaction releases gas because when the baking soda receives a proton, it transforms into water and carbon dioxide. When combined, the hydrogen atom in the acetic acid meets up with the hydrogen and oxygen atoms in the baking soda to form a molecule of water, while the acetic ion grabs onto the sodium atom and forms a salt, sodium acetate. The carbon dioxide molecule is free of its other chemical bonds and can now escape and bubble forth as a gas, which causes it to explode. When you mix an acid and a base in a solvent, water, in this case, usually the acid transfers hydrogen to the base to form a new compound. In this case, the new compound is called carbonic acid, which then decomposes to water and carbon dioxide gas. More precise definition of acids and bases states that a base is a compound that wants to donate electrons, and an acid is a compound that wants to accept electrons.